enjoying the very tight timing today? We're running just a little bit behind already before I even begin. For those of you who are already here for the Country on Stage program, welcome. The first time that Holland is presenting the Country on Stage program. I'm Jason Palmer, a journalist from The Economist. And we have problems? No. Oh, good. Very well. I had a chance to participate in last year's JEC, and this time I'm very excited to be here for what amounts to kind of a debutante party for the Netherlands, presenting itself as a key country, a key knowledge economy in the composites industry. I'm also very honored by the presence of Mr. Pieter de Gooijer, Ambassador of the Kingdom of Netherlands in France. We're here under the auspices of Composites NL, a trade body with a newly expanded role. It's blossomed in the past few years, forming greater involvement with Dutch universities, with foreign companies, with startups, and it's gotten the attention of the Dutch Foreign Ministry, who is also here, as we'll see. With the Foreign Ministry, Ministry of Economic Affairs, subscribes to this top sector approach, which is to say it pays lots of attention to industries with a great potential for growth. Now, Composites NL is working in a very integrated public-private environment, showing how composite technologies kind of are a way to address not just industrial concerns like shareholder value and local employment, but also tackling some global societal issues. Now, I'll tell you how the session is going to work, and we have a tremendous amount of material to get through, so I invite you to settle down and buckle up because this is all going to go very quickly indeed. First, we will have sort of a top-level chat about the composites ecosystem in the Netherlands from some people who know it best. And then we'll tackle things in a little bit more detail. We'll have short sessions on knowledge infrastructure and materials research, a session on startups and novel production technologies, a session on sustainability, sort of end-of-life concerns, maintenance, even recycling, a bit about market acceptance, which I imagine is not much of a problem among this audience. It's probably fairly well accepted in the market, but not more broadly. And then a bit about international perspectives. This is a Country on Stage program, after all. So, then we will get to the really important stuff. All of these ideas are embodied in what's called the National Cooperation Agenda Composites, kind of a country-level mission statement about, that will be formally presented to the Dutch Ministry of Economic Affairs here at JEC today. Lucky you, you get to be here for that. So, then comes clearly the most important part of the program, the networking cocktail afterwards, but I will be sharing details of that as we get closer to the end. As I say, we have a tremendous amount of material to get through, so we should get started with a little kind of introduction to the Netherlands, if you like. So I would like to begin to call the great many people who will come to the stage. Let me begin with Maarten Kamps, who's Vice Minister of Economic Affairs and Climate Policy in the Netherlands. Mark Hendrikse heads the high-tech systems and materials top sector we talked about in the Netherlands. And Marcus Kramers, Chairman of Composites NL. Gentlemen, hi there. I suppose. First, Vice Minister Kamps, today the Netherlands presents itself as country on stage at JEC for the first time, reflecting clearly a public-private cooperation in the Netherlands with high-tech, the high-tech economy. Why and how is the Ministry of Climate and Economic Affairs involved?
Well, it's actually not the first time that we're here. We were a guest country already in 2014.
All right, but as a country on stage?
Then it was called guest country.
Right.
Similar, I think.
Let's call it higher profile now.
Something like that. The fact that we were a guest country at that time has had an impact on the collaboration within the Dutch composite sector, within Dutch industry, to collaborate and to come up with a new combination of activities. And we're very honored that we are here now today to be country on stage. Now, why is the Ministry of Economic Affairs and Climate Policy involved in composites and in innovation? We are we face, in fact, two challenges. One is the economic growth. How can we sustain our economic growth also in the future? And second are the broader societal challenges that you just mentioned. And they are not just national, they are global. Sustainability and transport, clean energy, public security, these kind of issues. And we see that we need innovation to achieve these challenges, to really find answers for them. And the composite sector is an important, can have an important contribution there, with coming up with lighter and stronger materials that could lead to less carbon emissions, which contributes to our climate policies.
Sure.
So we have, to underline that, we have a mission-oriented policy for innovation where we are formulating these innovation challenges, these societal challenges, and we bring together research institutes, the business sector and government to collaborate together to make joint research agendas and to really innovate on these issues. And I think the composite sector is a very important sector to contribute to that.
Well, you won't find any disagreement here, I don't think.
I don't think so.
Mr. Hendriksen, the Netherlands subscribes to this sort of economic approach through top sectors. What's the added value of going about things that way?
Well, I think the biggest added value is that the incentive of the top sector structure helps collaboration. And as what the Vice Minister already said, it is that collaboration that made the difference. Especially if you look to indeed the composite sector, where you talk about startup companies combined with big companies supplying materials or fibers, knowledge institutes. So on the innovation side, the collaboration is very important. Not only that, also in what we call internationalization, where also the companies work together, present themselves together under the Holland High Tech brand, and present themselves as an important country to go to for these developments. And we're very happy now with about the 7th consecutive year of this approach. You see that this collaboration really starts to work very well, and it's there to stay. So we're very happy with this development.
Right, thanks very much. And Mr. Kremers, in that respect, what's the value proposition of the Netherlands composites industry?
Yeah, so the Netherlands has a long history of composite innovation. We have a very strong sector with large material science companies and Dutch companies, but also international companies that are active in the Netherlands. We have a lot of different applications in different markets with technology players. So companies that are not necessarily the largest companies in the world, but they're very focused on being technology leaders in their field. And we have a very rich landscape with technology institutes and field labs driving the innovation. So combined, we can create really exciting innovations and boost the international value chain. I think the international perspective is very important. So historically we have been doing this, and now we want to harness this capability to really contribute to solving the challenges for climate change and sustainability, because composites can have a very important benefit there.
Sure. A question for all of you today, perhaps the most important thing that happens is the presentation of this natural cooperation agenda, composites. What's the value in having such a thing? How does that support the Netherlands in the sort of international sphere?
Well, I think it helps to accelerate innovation in the sector within the Netherlands, but also in collaboration with industries abroad. It's an accelerator. It also accelerates the collaboration within the Netherlands between the triple helix, between research companies and the government. And we hope, of course, that it will contribute to finding these answers to these societal challenges in making materials lighter, make it possible to use it in a broader sense in products, so that we can achieve these challenges that we have.
I think we're in the forefront of a big growth in the composites. You see that mass production in composites is getting through. And to realize that, you have to work together, because not one party can do this, so you have to combine knowledge and experiences, big companies, smaller companies, nationally, but especially also internationally. And if we are able to do that, and this agenda helps in that, we can really get a boost in the composite production, I believe.
Yeah, I think these are very good comments. I think what I would like to add is that composites are used in a lot of different sectors. So people collaborate, but that doesn't go naturally. So what we try to do here with Agenda is to create a common goal, a common roadmap, so that everybody can join and we create more critical mass. So with that, there will be more investments from private companies. We hope also investments from the government to support this, and then we can create this much larger ambition and be successful.
Right. Just briefly, Mr. Komps, your job description is the Ministry of Economic Affairs and Climate Policy. Do you see those things as regards composites just sort of naturally intertwined?
Very naturally. Because it's, we are focusing on economic growth, and we are working on climate policy, which means reduction of carbon emissions. Well, the composite products, the component sector, is an important, can give an important contribution to our climate policy. So there's a clear link, and that's why we're so glad with this agenda, which may be an invitation for everybody to join and to contribute to the innovations and the developments that are going on.
Right. Well, we'll dive more into the climate particulars, sustainability issues in due course. For now, I'm going to have to keep saying this. We have to move on. But if I can thank you, gentlemen.
Thank you.
Now, as we kind of already had a hint of, the Netherlands has an extremely rich history of materials development and is renowned for strong links between its universities and research centers and its industry, in particular high-tech industry. And so we need to think about how that plays into the current push. So I now have the pleasure of calling up quite a crowd of people. We are going to fill this stage. First of all, Jos Lobé from Brightlands Materials Center, Bert Taus from Netherlands Aerospace Center, Sebastian Weiskamp from Thermoplastic Research Center, Kjeld van Rijswijk from Technical University Delft, and Rogier Nijssen and Moaz Gandhi of In Holland Composites. Can you all make your way to the stage? Is everyone ready? Hi there. Hey. Hello. Is everyone here? Do we have them all? Almost. Hey, good to see you. Hi there. Hey. Right, good. We're all here. I think the best thing to do, since there are so many of you, is just kind of start with a brief statement, not too long, about your respective research centers. Moaz, I'll come back to you sort of separately for some broader perspectives in due course. Jos, if you could start. Oh, we don't have enough microphones.
Is it on? Yeah, okay. My name is Bert Thuis and I'm heading the ACM Cube, which is one of the technology centers of NLR, the National Aerospace Center. And within ACM Cube, we conduct research on automated composites and metal manufacturing and maintenance. We not only do that for aerospace, but also for automotive, infra, maritime, oil and gas, etc. The high-tech, high-spec value chain.
My name is Jos Lobé. I work for Brightlands Materials Center. We are a material center. That means that we start from the material properties, looking at composites. We have a long history in the people present in our center in thermoplastics, and that is also the focus of the work we do in composites. We aim at overmolding processes, and we aim at recycling thermoplastic composites.
My name is Sebastian Weiskamp. I'm the technical director of the Thermoplastic Composites Research Center, based in Enschede in the Netherlands. We perform fundamental research on thermoplastic composites, so mainly looking at the process material interaction on all the processes involved to make a thermoplastic composite part.
Good morning, my name is Rogier Nijssen. I'm a professor at In Holland Composites. We're all about education, but we also work a lot together with many SMEs in doing applied research. As you've seen in the previous talk, SMEs are really the core of our composites industry, and they're also, let's say, the main market for our University of Applied Science. We've been doing applied research in, for instance, bio-based composites, also repair of composites. We focus in recent years mostly on automated manufacturing. And where normally you think about automated manufacturing on huge throughput, large series, we've been focusing a lot on vacuum infusion-based processes.
Jason, in 90 seconds, my name is Kjeld van Rijswijk. I'm heading up SAMXL, which is the Industry 4.0 ecosystem at the TU Delft University, which is the globally third-ranked university on aeronautical, mechanical and manufacturing engineering. We're a non-profit foundation with a participation model. Together with our industry partners, we develop Industry 4.0 manufacturing technology for lightweight structures, aerospace, satellites, wind energy, maritime applications. In our 2,000 square meter facility on the campus, our partners have equipment at their disposal to prove concepts, but also to scale up, hence the name XL. And we are, for our industry partners, a home away from home to conduct collaborative research without disturbing their own production lines. And at the same time, meeting our talented students and our thriving startup community. We are not limited to any type of material system, but coming out of the cradle of thermoplastics, it is one of our national strong points. And we look forward to welcoming you in our community and have a chat further.
90 seconds exactly.
90 seconds.
Feel as if you've done this before. I mean, what strikes me about kind of all of that is how interdisciplinary all of this is, from fundamental material considerations through to qualification and testing, design, the whole schmear. What we see in the Netherlands, though, is a very close alignment between research centers and universities and the industry. How does that dynamic kind of play into your own work in terms of perhaps faster innovation, cost reduction? I don't know who might want to take that one. If only we had more microphones.
Well, what we see in our research center is that we work crossover. So we work for aerospace, but also, for instance, for automotive. And we see that these worlds are different from each other. But they can learn from each other without having the troubles of having IP problems, because they're totally different areas that they work on. And this mix of technologies and mix of applications that we see also in our technology center speeds up developments, because we learn from each other. It's very important.
Sure.
And I think although we work in a global economy, it's very valuable to have. And the Netherlands are a small country, so within 20 minutes we are at NLR or at Fokker in Hogeveen, or maybe a little bit longer drive to Delft. So the communication lines are very short.
And I think maybe from the perspective of all the universities that we have in the Netherlands, there's still, let's say, the classical departments, but there's no department that's called automation of composite manufacturing, for instance. So we have to try and attract students from different disciplines and work together. That has the benefit that people are, let's say, stuck in their groove, get some new innovative ideas from students from other disciplines. But it has the added challenge that you actually have to attract, for instance, ICT students to go and do something with composites, which is, I don't know why, but it's not naturally in their system, except for printed circuit boards, of course.
Right, it seems to me that the sort of integration of these research centers, that the high-level view of the integration also with the Dutch government would be kind of seeing it as they functionally combine into one single entity, a national level innovation center. Does that seem like a fair view to you? Does that seem like a fair assessment?
I think, let's say, all the ingredients are there, because there is, let's say, regional or more or less local research centers everywhere that have their own, let's say, in-depth speciality and knowledge. But we're a small country, so looking from the outside, it's just, let's say, one big center where you have all these innovation possibilities. I don't know if anyone wants to.
Please.
I mean, together with all these centers, we cross all the TRL levels. We got experience from on the material side, the molecule side, up to the processing, the production side, the automation side, bringing in the people that talk software and robotics, and together with that, with an IP strategy where it's sort of like how to get to the market quickest. This is a very powerful group and combination.
I notice more than one of you, and in fact I might hear this again today, keeps mentioning how the Netherlands is a small country. It sounds as if it's very much punching above its weight then in the composite stuff. We don't need to keep pointing that out, I think. Moaz, coming to you, I mean, what do you think of that question in terms of the kind of a high-level innovation center?
I think from me as a student and at University of Applied Sciences, we work close to the industry in order to make that happen. So, like you said, the communication lines are very short. So, if the industry has a problem, it approaches the research centers and then, or the universities or University of Applied Sciences, and we as students will be able to solve the industry problems on point, and then we can directly, from our study, we are ready to go into the industry. So I think it is indeed a very good position to be in and have this short communication and being in such a large technological hub as the Netherlands.
And what do you see as kind of looking ahead a bit? What do you think a sort of genuinely national cooperative effort looks like?
I think that if really we cooperate and make even the communication line shorter, where the problems are out there and people share the problems, where the students and the research can find the problems to do more research on. And of course, the Netherlands is a great atmosphere from getting subsidies from the government. You had the vice president and vice minister, and he was telling us you can get subsidies. So if we work together with closer communication lines and we put the problems out there, it's easier to communicate to the government to get also funding to go further in our process.
Anyone else have any thoughts on what a national cooperative effort ought to look like, can look like, should look like?
What I think is that we should look at the needs of our industry and serve those. Doing research for the sake of research is interesting scientifically, but we're in a business, and we have to run, as a country, we have to run an industry and support that with new research. And looking at the topics there, I think thermoplastics are certainly offering a lot of challenges and a lot of chances also for the research institutes also to work together.
Anyone else? Well, we have a chance. Please.
I mean, at the moment, the coming together of the public and private sectors, from both programs, from working together on a structural level, and as well the formation of business parks around all the centers, the knowledge institutes, is something that is really, I mean, it was already there, but it's really picking up, and that swell is really making our lives a lot easier, that joint effort is happening, and that we can support that. Yeah.
Right.
Yeah. I want to add that I think that the role that the Industry Association Composites NL is taking is already a really good step forward, because they're, let's say, an independent entity with whom everybody wants to participate. They incorporate both the SMEs and big companies and research institutes, universities, University of Applied Science. So I think in bringing forward the National Composites Agenda, I think that's already a really good step towards, let's say, a joint effort, including a joint research collaborative.
Great. All right, well, again, we're out of time, but please thank our speakers once more. Thank you, gentlemen. Thanks. Thank you. Cheers. Cheers. Now, in every high-tech sector, you need, real, tangible innovation, things that genuinely move the needle. And in the Netherlands, we certainly see a lot of evidence of that. It's a vibrant field in terms of sort of startups, novel production technologies, and so on. So for the next round, I would like to call to the stage Lucas Janssen, founder and director of CEAD Group, Jasper Bouwmeester, Fiberneering, and Stefan Voskamp of Eurocarbon. You gentlemen ready? Might be running a little bit early. Pleasure. Hi there. Are we missing someone? Seem to be still missing someone, are we not? Right, very well. Well, please, come into the light. Easiest way to get going, of course, is to get you to tell me a little bit about what you do. Why don't we start with you?
Yeah, I'm Stefan Voskamp, General Manager of Eurocarbon. Eurocarbon is a company with 3 product groups, a major braiding and weaving company, overbraiding development, and also machine construction and series production of overbraided preforms. Nice examples is for the Lamborghini Aventador, braided rockers, crash structures, and A-pillars, and rockers for the BMW i8. These are nice prime products in our range.
Okay. And you?
Hi, I'm Jasper Bouwmeester. I'm the founder and CEO of Fiberneering. And basically what we do is we have developed a 3D printing method to produce carbon fiber composite parts. There's a lot of 3D printing out here on the show as well. And that's almost everybody is putting filaments down. We do it different. We use liquid resins that we cure with UV. And we use that as a core. So we use 3D printing really for the shape and for creating the free form. And then we apply the fibers in a more traditional way. And that allows us to create really high-end structural composites with high fiber volumes and high properties.
Right. And just in time.
Thank you. Sorry for the
Not at all. But why don't you introduce yourself? Tell us about what you do.
Sure. My name is Lucas Jansen. I'm one of the founders and directors at SEED. And SEED is a technology supplier on the frontier of composite additive manufacturing. Sorry, I ran here.
It's a busy day, we know.
It's a busy day. But we actually combine continuous fiber on a very large scale with thermoplastics.
Right, okay. Now, Stefan, if we could start with you, because in a sense, a lot of the discussion around innovation kind of always focuses on the role of startups, and everybody wants the newest, greatest thing and so on. Eurocarbon's not a startup.
No, we are since '82 founded.
Right.
Yeah.
But a startup in its time, I suppose, based on a novel technology in its day.
Yeah, there's always time to start a new technology. Well, we started a kind of new technology, overbraiding, in '94, and continued developing know-how on this. So it's overbraiding is a good technology where you can deploy fibers directly on the core in your required angle, fiber orientations, and also possibility to integrate UD fibers for bending loads, and the braiding fibers will give the torsion loads. So it's a very effective method of automated production, and big automotive suppliers have recognized this technology. And we're working on that since '94, building our own machines to do our own products, and I think that's a unique combination.
And why do you think the uptake has been so strong, in particularly in the automotive sector? What do you think sort of pushed that along?
Yeah, it's a repeatable process. If you do RTM infusion, you want to have consistent freeform, a stable production process, and it's automated. It's just like a 3D printing. It's an additive manufacturing technology, and the low waste we generate is at the beginning and the end of the preform. Everything is computer controlled, and therefore repeatable. And that's the cost driver is a main factor in automotive. And this is certainly a good, interesting technology to do these sometimes very complex parts.
You make a good success story here. You make it all sound very easy. Why don't you tell me instead what the sort of challenges were in getting kind of a novel approach, a novel material, kind of integrated into the market like that?
Well, difficult is always the geometry we would receive, and it starts with getting the geometry and the required fiber angles, and based on that and the production numbers, we will look what is the best approach. So the braiding, it's a single element in the process, but it's the whole automation, how to get the core in the right way in the machine, which fragile core material is used, and to get to the end price for the customer, which is attractive, and providing all the benefits it has to offer.
Right. Now, Lucas, if I can come to you, how did you develop the idea for your technology, and maybe just a quick review of what exactly it entails?
Sure, thanks. We actually came to the idea because we were involved with 3D printing for 10 years, and we were mainly focused on consumer markets and prototypes, and eventually we were very eager to take the leap and really bring the 3D printing technology to end applications. And therefore we thought you need to be able to make big parts, you need to make them rapid, and you need to have high mechanical properties. And therefore, we really wanted to introduce the fibers, glass and carbon fibers, short and continuous fibers. And I think that's also the essential part of our technology that makes us worldwide unique, is that we can, on a very large scale, combine continuous fibers with thermoplastics at a very high speed, making it an efficient production method for facade cladding elements for buildings, front skirts for trains, so exterior panels, even pedestrian bridges, or tools or molds for the aerospace industry.
Well, I mean, you mentioned a lot of industries there. There seems to be a lot of uptake kind of across the board. How do you think the company's involvement in the Dutch innovation ecosystem more broadly kind of helped that spread?
I think there's a lot going on, and from the start, we really put an emphasis on working together in a collaboration with our clients. So really in terms of partnerships, because the customer eventually knows what requirements they need for their application. And those insights for us are very important to work together with them and to actually bridge the gap between a novel and new technology like ours to really the end applications. And I think that's the big challenge. For example, we have a launching customer, Poly Products, where we do exactly that in terms of bringing the technology to facade cladding elements. And they're going to do 2,000 facade cladding elements in the couple next months to produce that. And I think that's an excellent example of how we collaborate and get insights for these applications.
Right. And Jasper, about your technology, a very different kind of 3D printing, obviously, and perhaps it's worth kind of reviewing how it's different. But what was the sort of inspiration for forming a startup in the first place?
Both from a personal interest. I really like starting something up, being in touch with customers and coming up with new ways to do things. And actually the picture that's up here, that's one of our products, which really shows nicely what kind of products we want to make and are making at the moment. This interior structure is all 3D printed, and the outside is a carbon fiber part. And the beauty of it is that you can actually include all kinds of sensors, all kinds of cable ducting already in the print, making the assembly process later on hugely more effective and efficient. We don't need a mold to make this, so we can make it directly out of the computer. The product is just a lot more effective, a lot better product. And that's exactly why I wanted to start up this company, because I believe in this kind of technology. I believe in composites in general are a good answer to a lot of questions in the current environment. And I think it's a nice way to put a new technology in the market.
Right. So sounds a little bit selfish, I suppose. You just wanted to make a cool new thing. Yeah, no, that's it. It's the best way to do it. Eh? If you can enjoy what you're doing every day, then that's a very good way to be going around. But a similar question that was for Lucas in terms of how much the kind of spirit of innovation of the Netherlands kind of helped, kind of being part of the broader ecosystem. I mean, how did that go for you? You see that there's a lot of knowledge in the Netherlands, and that's a very good thing. I think one of the difficulties is that with every innovation you need clients to start using it. And the reality is that a lot of our clients are not necessarily in the Netherlands. So I think the innovation spirit is really there. Really what we need is big companies wanting to try new things, and that's always the challenge. Just welcoming new ideas. One of the themes that we're kind of not having a separate session on, but it's always kind of worth tackling, is the degree to which these new approaches either reduce costs overall or increase the quality of the finished product, or in the best case, both. Perhaps you could each have a turn talking about how your technologies are trying to do both or either of those things. Can I have a go?
Yeah, I mentioned it a bit before. The braiding process is a really quick process where, for instance, you can deploy 216 yarns at the same time, very efficiently, applying a lot of material in a short time, and the waste rate is very low. Repeatable, different complex shapes. So these are very important cost drivers and cost savers.
Right.
So there's actually two sides to this. So for small series, obviously 3D printing is great because you don't need a mold and you can produce very fast straight out of the computer. So that's a no-brainer. That's cheaper than what you do if you do it traditionally. But also on the larger series, we're looking at a few thousands of products per year. We still believe that we can compete to traditional methods on a cost basis as well.
Lucas?
I think it's a little bit similar to your story. I think the difference is that our technology mainly focuses on big structures. And these big structures, if you look at the maritime industry or buildings and construction or the infrastructure, are mostly manual labor. And well, that's not necessarily a bad thing. It was a driver to actually bring a lot of the production facilities to Asia, where they're manufactured more cheaply. And I think that the technology that we've developed is the bridge to bring it back again, to make it sure that you can do it locally. Because these big structures, they often are produced in very low volumes, and therefore a lot of manual labor are involved. And a technology like this, in 3D printing in general, has the ability to tackle those problems and to be able to produce in very low volumes very efficiently. Yeah, that's a key driver to bring that production back and to produce locally again.
Yeah, and I suppose that I mean, in the case of kind of all additive manufacturing, there's kind of a reduction in wastage that is the same thing as being sort of being more environmentally careful about exactly what resources you're putting in and getting out and so on. Do you think explicitly about the sort of environmental impacts or how to improve them, or does the process do that for you?
For us, it's a very important thing. We have developed our own printer, but we also have developed our own materials. Currently, it's a rather traditional chemical mixture, but we are also looking at bio-based resins to include in our process. We're looking at thermoplastic resins produced in a more thermoset way. So there's definitely things we look at, and it's also a question we get from our customers, by the way. So it's an important topic.
Well, for us, it's depending on the product geometry. Ultimately, you can end your preform and directly continue with the next preform. That way, the waste rate is really low. So that's that's really a good opportunity if the product allows it.
Right.
Yeah, we completely focus on thermoplastics, so they're recyclable. And I keep coming back to the facade cladding example, but there they've used actually old PET bottles, recompounded those with glass fibers to gain the correct mechanical properties. And yeah, those are going to be installed. So old PET bottles become face cladding elements for a building. And I think that's a good example of what technology like this can do for the sustainable world, and really advance those materials and recycling processes that we need and that we're all looking for.
Right. How convenient then that we're going to be hearing very soon about exactly that. But for now, I'm afraid we're out of time. So, and I mean it out there, I want you to thank these guys. Thank these guys. Thank you, gentlemen. Right. With that then, a little bit sort of foreshadowed by the last talk, we're coming to another real strength in the Netherlands, which is investigating how composites can sort of increase sustainability in a bunch of ways, lower emissions in a bunch of ways. Not only about sort of recycling in the direct sense, but also general end-of-life concerns and maintaining what's already out there, concerns around maintenance. And the recycling business isn't really just a matter of, grind it up and use it as some sort of filler. I mean, what we're all looking for, I suppose, is a kind of genuine second lease of life for some of these materials. But not an area of expertise for me, but luckily I'm going to have some help in this one. So next up, I would like to call to the stage Marco Brinkman, the Development Center Maintenance Composites, and Margie Top of Windesheim University of Applied Sciences. Okay. Okay. Hi there. Sure thing. Hi there. Okay. Very well. Good, I get a break too. Where shall I sit? Why don't I sit here? Ooh. Right. Welcome to both of you. And by now, you know the drill. Let's start with just a brief description of your work and sort of how it figures into this broad topic.
Shall I start?
Please.
I've been, as an entrepreneur, working for 20 years in production of composites and the last 4 or 5 years in maintenance of composites. And after producing so many parts, I also saw that it's very important to think about the next step. And one of the ways to look into sustainability is maintain. So extend the life of composite use. And because of that, and we saw a lot of initiatives also around the Netherlands and also in Europe, we thought of how to combine and how to concentrate these skills, not only in composites or in companies, but also in institutes. And we started a foundation, the Development Center for Maintenance of Composites, and I'm the chairman, so I can explain a little bit more about that.
Okay, I mean, please do. May as well while we're here.
Well, it's an open foundation existing of small companies, large companies and institutes. So there are 4 founders. JEC and Fokker is a big company. It's one of the members. My own company, Specto Aerospace, maintenance company in the aerospace. The University of Delft, who was also on the stage before, and the National Aerospace Laboratory. So these actually were the founders. But it is an open way of organizing, so we run different projects, and these are also across markets. So for instance, we have a project in the shipbuilding industry, looking into the maintenance of thick wall composites, which is completely different, and also how to inspect that. We look into automotive as well, because we know exactly how to do this type of maintenance activities in the aerospace, but in the automotive it is really growing, as you know. More and more cars are produced, and car maintainers are struggling with how to maintain composites. And another area is the windmill industry. You can understand how to maintain a big structure like that, many times offshore. So we have different projects looking into the future of maintenance of composites.
Right. And Margie?
So my name is Margie Top. I'm a professor for polymer engineering, University of Applied Sciences, Windesheim. And my group actually focuses, together with mechanical engineers, civil engineers, electrical engineers, industrial product engineers, on anything to do with plastics and composites engineering. And I'm here today to present our project on the end-of-use life of composites and how you can rework that into new construction material.
Right. I mean, shall we have just a summary then of that?
There's very conveniently, there's already a slide on.
It's almost like they worked that out for us.
It's actually a project that started 4 years ago at the JEC. Because the advantage of a small country, actually, is that we know each other very well. And what happened 4 years ago at the JEC was that CTC Composites, that they actually offered us a windmill blade. So we came back, we were on the train, Jasper remembers because he was also there.
On the train with the blade.
On the train, going back to the Netherlands, and we said, we were offered a windmill blade, what are we going to do with it? And out of that moment, actually, the project was born. And first of all, you want to do something that's applied science, that's our business. And you want to do something that makes sense from a business point of view. So what we started doing is that we can start coming up with ideas on how you could actually rework old composite material into new profiles, into new construction panels, into, well, I just saw the lockers. They're actually at Windesheim University. I saw the retainer wall. Look, that's us. We produced 30 meters of retainer wall. That was a Compo World project. And one of the nice things, and I hope that slide's going to come up next, is actually that the advantage, again, of a small company, a country, is that it's very easy to close the whole value chain. And for lots of companies and lots of knowledge institutes to work together. I'm hoping the logos are going to come up. It's not. the beauty of this project was it became so successful that at the moment there are 35 companies, but also local governments, waterschappen, which is definitely a Dutch invention. So it's the people governing the water system in the Netherlands.
There's a vote coming up soon, if I'm not mistaken.
Yeah, recyclers, shredding companies, alliances for the resins. There's so many people involved. And I think that's why we've been so successful with this project. And that's why we have demonstrators now all over the Netherlands. So we're going to have these retainer walls, we're going to have berthing structures in Friesland. There have been beams for bridges, the construction material, the locker material. And again, yeah, we're small, but we do well.
Well, I mean, you've given a few examples there. Let me ask the more general question. From what you've seen so far, can composites be recycled?
I'm going to give an answer that is our methodology that was developed by our engineers is mostly applicable for thermoset composites. So we've developed something for thermoset composites actually produced either by hand lamination, vacuum infusion, or windmill blades, the refrigerator truck panels, anything that can sort of be shredded again and that we can sort of compress or in a different way, pultrusion, rework into a new construction material. So I'm not saying anything about thermoplastic composites. That's a different group in the Netherlands. I'm not sure all thermoset composites will be suitable, all products from thermoset composite will be suitable, but for a very large chunk of the market, I think we have developed a methodology that looks very promising.
Okay. And identify the applications that are kind of most suited?
Civil engineering. So that was actually a very nice match because of my team, the mechanical engineers building new equipment to produce this automatically produced material. The civil engineers who actually made sure that it will be positioned in the country, so the retainer walls, the berthing structures. So it's actually a very nice match. And the electrical engineers will start building in all sorts of sensors to make sure that we can do monitoring off-site as well to see how all these sort of structures will hold up.
And what about the economics of it, though? I mean, if you want to recycle anything and you're willing to throw some money at it, you can recycle anything. How about the sort of the concerns with respect to costs? How does it look?
If you do it in an automated way, it will work. If you start doing it by hand and start making new construction material out of it, it will definitely not work. There was this picture again of the lockers, and you saw the W from Windesheim, and we did that in a batch process. That was simple compression, in that case a polyurethane resin. It takes a lot of time. So anything that's a fully automated process is definitely the way forward for a good business case, and it's looking very promising at the moment.
Okay. And Marco, turning to you. I mean, again, this is not just a matter of recycling. Long before that, things are out there in the field and need maintaining. What's the sort of knowledge base in the Netherlands on maintenance?
Well, it was said before, we're a small country, but there's a lot of activity going on. And I said also that we try to bundle this knowledge base. But what we also see is that there is always a gap if you try to innovate between what's done at the universities and what the companies are asking for. So this is kind of called the value of that. So sometimes developments stop and they're not continued because of this gap. And that's the reason why we started this development center for maintenance of composites. Because there is a lot of knowledge, but the innovations that the companies are asking for need this type of organization. So for instance, it was said before that automation is something that we really need. Also in maintenance, you can understand that if you have, for instance, a structure of an aircraft or a car, if you like to maintain this, there is always the need to take away paint. It is a very labor-intensive process and not always healthy. So one of the projects that we're doing at the moment is to try and automate this decoding process. And there's a lot of interest, especially also in the international market, for these type of solutions. So we're testing different concepts there on component level and maybe on complete assemblies. And you can better do that together than for each company for itself. So that's an example. And the other thing, in composites, it's very important that you know how to inspect structures. So, for instance, when a car hits another car and it is a composite one, usually in metals you see a dent, but in composite it's not always like that. So maybe from the outside it looks okay, but from the inside it can be completely debonded. Maybe you recognize that. So the way to inspect is something that we like to do more efficient, especially for windmill blades. It's very large. But to work on these topics, yeah, we can really make good steps forward. So there's a lot of work still to be done.
Well, exactly. I mean, it sounds as if you're kind of finding some kind of new frontiers already. But I mean, as the focus continues to come onto sustainability issues more broadly, what are the sort of innovations you kind of expect on the horizon? What are the big problems yet to be solved that you haven't even yet thought about?
Well, I think it is also kind of educating the producers of parts, because for many years the big focus was in the composite world how to produce these advanced structures. And there was little thinking of how to maintain it, or to recycle it. So it is important to think as a designer or an engineer also at the end of the life or the usage of the part. If you look from an economic point of view, usually in the aerospace, 2/3 of the turnover is made in service. So 1/3 is production, and then 2/3. So you can see it's really a big part of the whole life of the part that is of the uses of the structure. So we think it is important to think about how to recycle and how to maintain a structure when you design it.
Okay. One final question, actually for both of you, but here's the challenge. You're not allowed to use the phrase, the Netherlands is a small country, in your answer.
Which is an advantage.
I'm just wondering why you think the Netherlands is kind of the place for innovations in exactly this kind of stuff, and the degree to which you think the Netherlands can be a world leader in solving exactly these kinds of problems.
Well, one of the reasons is that we have the complete supply chain. It was mentioned before, we have materials producers, we have the institutes, engineering firms, producers, and we always were looking to the international market. So one of the things that you know about the Netherlands is that we're open and always looking to the export. So we because we are as we are, we're also not really a threat. So, and I think we're lucky about having this high knowledge base and be able to team also with skills and other partners in the international world. So that's why we are here. We're not here to, well, we're here also to meet with our Dutch colleagues, but mainly to discuss also potential collaboration with international institutes or companies. So that is always what we have been doing for ages, and we'll also do on the side of innovations.
Right. Any thoughts on that?
Yeah, I tend to agree. The Netherlands, we've always been very entrepreneurial, and I think that's key. I think that's key to a thriving economy. I think it's key to inventions, to innovations, to go ahead. If you're not entrepreneurial, whether you're a researcher or whether you're a business, you're not going to go anywhere. So, yeah, entrepreneurship, that's Holland.
Simple as that. Right. Okay, well, unfortunately we find ourselves again out of time, but let me personally thank you guys for your time.
Thank you.
And everyone else, please join me. Been a pleasure. Thank you very much. I am sorry for the rush. I know this keeps happening, but there is a networking cocktail to get to, and I keep that forefront of my mind. I don't know about you guys. It's it's all well and good to have kind of a technical solution and to be able to, speak to a buyer, a purchasing manager, or what have you, and say, I have a new, important, and valuable thing. But it's quite a different matter to get it sort of, to convince a market that that is the right product for it, as I'm sure many of you in the room are already familiar with. Inertia certainly plays a role. Standards and certification play a role. Matching standards to good new technologies is not easy and fraught with all kinds of red tape and bureaucracy and what have you. But there are a few Dutch entrepreneurs who have kind of navigated these waters, as it were, already. So we're going to have a little bit of a chat with them. To that end, may I call to the stage Martijn Veldkamp of Fibercore Europe and Arnold van Drager, owner and founder of Wabo Composites. Hello. Okay. Hi there. Now, I'm going to give you 3 guesses what happens first. No? Okay. You just get to tell me, and indeed all of these nice people, briefly what it is that you do. Let us know what your companies are up to, first of all.
My name is Arnold van Drager for Wabo Composites, and we are a company building structural elements in the marine sector and also for industrial solutions. And beside of that, we have our own product, and that's the composite ship door and fire rate and waterproof.
Okay, tell me a little bit more. I mean, what's your main big seller?
Yeah, okay. Well, we're building the product, so we do it from the beginning to the end. The calculation, as the picture you can see there. We build a big antenna mast and the canopies in the top, on the top of the vessels, and beside of that, composite ship doors and hatches.
Okay. Martijn?
My name is Martijn Veldkamp. I'm a senior design engineer at Fibercore Europe, and we're here together with our associated company, Infracore Company. And what we do is, we build structures, as you see on the screen there. It's like big structures, and what you see is bridges and lock gates. But actually, it's more about the panel that's inside, as it's the technology on how to make that panel and to make it resistant to impact and fatigue. So it's a technology company where we're looking for applications, and it could be in civil engineering, but it could as well be in offshore or maritime, or even others that we don't know yet about. On my role in the company, being a design engineer, I link the client wishes and I try to translate them into a technical solution, a proposal that we can also first design and then build. And yeah, that can be to any scale or size, and yeah.
Okay. And what are the challenges that you've run into in terms of convincing customers about a new way of doing things?
Well, bringing FRP or composites into civil engineering is like a new market to these clients. They're not used to having FRP in their domain. So what we see is acceptance is really a big issue. Everybody understands that FRP is a very good material, but they cannot envisage it in their in the traditional world, where traditionally there was steel and timber and concrete. But we have we're courageous first clients that build the first projects, and then there's others that see them, and then from that it moves onward. And avoid that it's a small country, but you know the sentence that comes next. The other thing really is scale. That there's high-end structures here at the JEC. There's also very big structures, but the most big structures at JEC, they are repeat products, whereas all the structures that we build, one after the other, they are bespoke, they're custom made, custom designed, and still we can make them up to like 40, 50 meters. So you need a lot of confidence in what you do, and hence the technology again that we do. But we do a lot of the same, but always in a different sort of way. So we learn from that and build on from there.
Right, okay. But you are talking about sort of larger, again, one-off bespoke infrastructure projects. When it comes to civil engineering, I would have guessed that standards and certifications and what have you become kind of a problem. People want to be very convinced that their bridge is going to stand.
Yes, they would. And also there's the, building for the public. We're talking about public structures and also public clients. There is, of course, the regulatory framework. And again, It's the Netherlands that was one of the first ones to have design codes, especially for infrastructure, for FRP applications in civil engineering. So although it's not yet to the full-scale legal level as there would be on the European level, still it is enough to build safe structures and also to justify that to clients. And then together with the experience that is gradually building up, and also the and it's internationally that people recognize that. So we build our structures all in Holland, but we bring them across the world. So there is a lot of showing that you can do it. The demonstration gives the viability and also gives the confidence to the clients that it would. And of course, that needs to be followed by legal aspects in design codes, etc. But there is a lot of testing that has been happening in this. But you need to have the projects first before you start actually to write the design code. I mean, you need design code is there to confirm really.
Right. And Arnold, turning to you for the maritime market, I mean, how do you sort of convey the added value of composites for that base?
For the clients, you mean? Well, basically there are a lot of benefits in composite material, there's maintenance, etc. But the main thing they're looking for is saving weight, because maintenance is of course nice for the business case of the owner, but we have to deal with the yards, and the yards just looking at, if to be honest. What we miss, you mentioned as well, the composite material is not an option during the design period. And then is what you see, they go up starting with a steel hull, because a ship is all steel, of course, and they go to aluminium to save some weight, and then in the end they cannot find a solution in aluminium, then they go to composite material. So then saving weight is important, of course. But to be honest, I had a discussion with a client, well, why it's not an option? Because you want to pay more for aluminium if you want to save weight, but in the end, you don't want to pay more for the composite material. And he latterly said to me, well, I was not desperate enough to choose for a composite material. So I think it's also important for us to have some education also for the people who are working by our clients as well in the office for acceptance for the composite material, to see it as an option in the first way as well.
Well, I mean, that's the question. If people haven't been sort of, confronted with it before, they don't know what the strengths are, the sort of the ways that it can help in a particular application. I mean, what form might that education take? I mean, besides the great people of JEC, right? Yeah. A more informed audience.
Yeah, maybe also a part of the education sorts already now. It's not especially maybe if we don't have to choose for a composite education, but also in the normally basically engineering education parts, maybe there is also some space for composite as well. So you don't have to have plenty more composite engineers, but also the engineers is working with steel and aluminium. They need some knowledge from composite material, because then they can see it as an option in the beginning when they start to develop a product or to develop or make a new design or whatever.
So we have to break into the engineering universities and teach them then.
Start there first.
You were going to say?
Well, it's also it's not just the knowledge that the new students need to learn, but it's also the attitude of how to deal with new things. They need to question why not build the mast of the ship in FRP, because factually it's the best material. For a bridge, factually it's the best material. it's lighter, it lasts longer, total life cycle costs are lower. So why not do that? And it's especially the younger generation that is more open to try new things, because they face new challenges, and they're clever people, but kind of sometimes history is an obstacle. And you need to get beyond that, and that is what, as the older generation, we need to encourage them to do that, and let them do that, and also to the point of doing demonstrator projects. Build one of those ships with those yachts. Build one of those bridges, and then see how it works, and then decide, and not beforehand say no.
Yeah, I agree. If you start with showing, of course, product, to be honest, if every ship now needs a composite mast, then the composite industry has a problem as well. But I think it starts with knowledge by the customers. That's important.
Well, and familiarity to a degree, right? It's a sort of a chicken and egg question. If people aren't familiar with it, they haven't seen it before. If they don't have a friend who has one, then they don't know. They know that steel and aluminum certainly go back in history, but composites doesn't. I mean, there's a certain element of building trust in the material itself, not just knowledge about, I suppose. I mean, have you in your travels dealt with any sort of straight trust issues rather than unfamiliarity?
Yeah, always, because because you have to see it like this. They're building a 200 million vessel, and then they have hand over a very important part of the vessel to a company with maybe knowledge, and they cannot see what we do, they cannot follow it, they cannot check it. So yes, that's a thing.
Yeah, what we see is demonstrate, show, explain, and never hesitate to tell the story again. I mean, this is quite an easy audience, as you all know what composites are. But it's not just about you, it's about the people that you meet back home, I mean, what they are going to do. I mean, it's for the end client. So those are the ones that need to be convinced. And yeah, that's...
Well, but also when it comes to cost, right? In a lot of cases, they're going to be paying over the odds for it, and they aren't going to know why they're paying over the odds for it. I mean, I presume anybody trying to break into these markets has to fight that too.
It's not always cost, because our hedges are built in a very smart way, so we can do it for the same price as aluminium. But there's acceptance. But to be honest, they won't also pay more for aluminium solution. So I think basically, if you start from the beginning as an option for choose for composite material, price doesn't matter, I think.
Say that even in some applications FRP would be initial cost cheaper than other ones, but it's just that you need to be open to ask whether another material could be applied in the first case as well. So that's it's never too late to ask, and also yeah.
It is from business case point of view. It doesn't matter the cost, of course. You have to see the calculation. But what we see, I think, if we start with the yard and the owner in the beginning to discuss the business case, etc., I think there's not a problem. But if you calculate your budget as a yard with composite of aluminium material, and then in the end you start with you use a part of your budget to engineer the aluminium, and then in the end we have to save the project, and then you see there is no budget enough or whatever, but or they have to find some more budget, of course.
Right. And you mentioned earlier the environment for getting things certified, standardized, what have you, has proved fairly straightforward. I mean, do you both feel that way, that in terms of bringing materials into new markets is made easier in the sort of, the innovation ecosystem in the Netherlands?
Well, building things into the offshore and maritime, I mean, that's not exactly a Dutch business, but it's, I mean, ships going across the oceans is quite quickly becoming international. But of course, it helps that you see these big yachts by my colleague here. I think your ships and your masts, they are kind of like a visitor business card to the use of FRP as well. So it's a kind of, we need to be proud of all those products together, and that will open the doors just as much as showing a 40-meter bridge might help, getting your mast, give the confidence in.
Yeah, there's one thing, because in the yacht industry or the naval industry, it's easier, because if you go to the let's say the commercial vessels, we are really interested in, because there's the big market, of course. Then price and paperwork is more important. They want to buy from the shelf, because if there is a yard, there is one goal. The yard had to sail like the owner wants, and how you came there doesn't matter, just fix it. And then budget is easier, you can make the discussion with Lloyds or Veritas or whatever. But for the commercial vessel, I think we have to do a lot also together with class societies, because they all don't have the rules. Then steel is steel, or non-combustible is a nice word, of course. So yeah, there's a lot to do.
Right. It seems to be a recurring theme that there's lots to do, but also in this session. So for now, gentlemen, thank you very much indeed. And if you all could thank our guests. Thanks very much. Cheers. There is, of course, an international perspective to all of this. This is the Country on Stage program, after all. The next thing to do really is to talk about the involvement of the Dutch composite industry and sort of the global supply chain. And there are a couple of notable international firms that have set up shop, in fact, in the Netherlands. So to talk about that a bit, I would like to invite to the stage Luc Govaerts, Technical Director of SABIC, Frank Meurs, MD at Tenkate, and Hendrik de Zeeuw, Senior VP at Teijin. Can everyone come on up? you work yourselves out in the right order. Is everybody happy? We have too many chairs up here, and one too few microphones. Are we happy to share? Okay. Luc, if I could start with you, how does the Netherlands sort of fit into the global SABIC supply chain?
Well, let me start by saying a couple of things. As a global company, we have many options to make investment decisions. And you can always refer back to the triple helix, where you think about government, academia, and industry. And is that ecosystem in place to provide and drive innovations for enabling the mass adoption of thermoplastic composites, like what we are aiming to do? From a government perspective, we know that in the Netherlands, the country and the government is providing the right opportunities for collaboration, for innovation, and creating the right environment. And that's what you see consistently, that the country has been listed in the top of the innovation index. When you think second about academia, having access for developing really breakthrough technologies like we're doing, you have to have access to world-class institutes and universities which are present in relatively short distance. On top of that, it gives you access to skills, capabilities, and talent, especially in today's war on talent. It is important. And also the fact that you're very close to Germany and Belgium, with also top-notch universities and institutes, is a critical element. And the third pillar of that is, of course, industries, because when you want to develop a mass adoption of these new novel technologies, you have to be close to other players in your value chain. And that is what we've been doing. The country has a lot of, and it was mentioned in one of the previous talks, a lot of small, medium enterprises and a lot of very innovative startup companies. And what we have done is we tapped into that community to enable and help us co-develop elements of that value chain with, for instance, FRT, where we have a majority investment to develop our UDMAX tapes, which are a key enabler for us based on a proprietary impregnation technology, one. Another example is airborne, for instance, where we are collaborating with deeply to enable automation, because when you want to develop something like this, it needs to be with the right quality, reproducible, the right cycle time, and ultimately also the right cost. So having multiple elements of that entire value chain combined with having access to materials is critical. And that is why we decided to put our innovation center in the Netherlands, in Geleen. And yeah, that's in short what we are and why we made that decision.
Right, fair enough. Preempted my second question about the talent economy, but okay, good. Frank, Tenkate was acquired not so long ago by Toray. What do you think each company kind of does for the other?
Well, quite a few things. Toray acquired Tenkate predominantly because of the supply chain into the aerospace industry. And well, here, the fact that we have, and it was mostly around thermoplastic composites, and that's been a journey of 25 years plus, where they have always been our carbon fiber partner. And well, the whole ecosystem in the Netherlands have been very visible. So that has certainly played a big role for them. Also, the long relationship that we had, they felt very comfortable, let's say, with Tenkate as a company. So what it does for us is, for Tenkate, we got to a point with our developments that we were basically, as a composite material player, we were too small for the real bigger opportunities. And being part of Toray, which is really a technology powerhouse in the composite industry, helps us in many ways. And it started with, let's say, the way we're perceived by the OEMs is already different, and we see that. and it's been expressed by the OEMs. So we are a more credible partner for, let's say, serious future aerospace programs.
And in terms of the sort of innovation sort of ecosystem that's available in the Netherlands, how does that sort of play into what foreign firms think of the market here?
I would say the whole ecosystem in the Netherlands was a big part of let's say, how we got where we are. And it's still going on, it's still developing. One of the projects that we can mention is Tapas, which was very Airbus focused, but also TPRC in the Netherlands, which was on stage here. And that all helps, because I heard about the supply chain today, and it's really bringing innovation onto a new aerospace platform is all about integrating the entire supply chain, and from the innovation phase on. And that's essentially what happens with that ecosystem. Having said that, for all the players in the Netherlands, and we grew together, but it's also very important that we find our way, let's say, in the global markets together, but also independently.
Right. And Hendrik, when we spoke earlier, you mentioned the dense entrepreneurial spirit in the Netherlands. Tell me what you mean by that.
Well, let me comment on how you introduced us by saying international companies that set up shop in the Netherlands. Actually, they took over shops in the Netherlands. And I think that actually kind of summarizes the essence of what you see in the Netherlands when it comes to the composites industry, but also to other industries. There is a very entrepreneurial spirit of setting things up. And I think it's also one of the areas in the world which is probably the most international focused. So that brings a lot of attraction to companies around the world to say, hey, we see something interesting and we're willing to build on that. We have 2 companies sitting here, both were owned by Japanese companies. What I notice from my Japanese colleagues is that they are always very much admiring our international focus and how we are capable of dealing around the world. It made our Japanese mother actually decide to say, well, instead of us taking over the Dutch aramid business and starting to manage it from Japan, we rather have you from the Netherlands manage our aramid business in Japan. So I think that
feels like a bit of a compliment, doesn't it?
Yes, it is a compliment, and I think it's definitely a compliment to our organization in the Netherlands. But in general, I think that's what you see more throughout the Netherlands. There you have a dense network. It's fairly well organized. The international focus is there. We have a culture which is very multicultural. That makes it also very easy for people from outside to root in the Netherlands and find their place. And that's also what we see, for instance, in our R&D institutes, where we have people from all over the world working there, and with a lot of pleasure.
One last question for all and any of you, because we're on the cusp of seeing the launch of the national cooperation agenda being launched here. What value do you think that presents to foreign firms in the global market?
Well, I think what it does is, and for the global market, but it gives direction, coordination, roadmap to all the developments. And we are past the phase of, let's say, the fundamental things. Everything we're doing now is really focused on larger new applications. And that needs a certain level of coordination.
Yeah, it's efficiently reducing it to practice. How do you make it reliable, high quality, consistent at the right cost, and being able to recycle and reuse? And setting up that infrastructure, that network is critical.
Having one sort of unified plan for all of that surely looks good to a foreign firm, even if it's a matter of taking over rather than merely setting up shop.
Absolutely.
Right. Gentlemen, once again, I'm afraid we're out of time, but thank you very much.
Thank you.
Thank you.
Thanks. Cheers. Cheers. Take care. Well, we're getting closer to that cocktail. But we've come to an important part of the program so far. What we've been doing with the Country on Stage program is kind of communicate the value proposition of the Netherlands composite sector. And that's based on a lot of kinds of cooperation, right? Cooperation between the public and private sector, between regions, larger, smaller businesses, universities and research centers. It is a national cooperation agenda. There's, the clue is in the name. And we've seen how different, sort of institutes provide that national knowledge base for entrepreneurs and who see, an opportunity to tackle some of the global societal challenges that we've at least touched on in 10 and 15-minute chunks throughout the session here. Economic growth, sustainability, health, security, all these things are tied together. I think it's fair to say we're all behind those motherhood and apple pie kind of concepts, but the national agenda does try to bring these things together, and that is the value driver. That is what has, kind of come out of what amounts to a lot of cooperation that's gone on in the Netherlands for centuries. So, at last, I know how you've been waiting for this part. I need to invite some people to the stage for the formal part of this. Again, if I could invite up Marcus Kremers to hand over the National Cooperation Agenda composites to Martin Kamps and Peter de Gooijer as representatives of the Dutch government, and Marcus Hendrikse and Oscar van den Brink, representatives of Dutch industry for high-tech systems and materials, and the top sector, Holland Chemistry. Everybody, please come up. Oh, it's official. I wonder if I'll get my very own copy. Sorry. There. It is official. And Mr. Kamps, I believe you have a few words to say? Different speech? Wrong event. Congratulations to the bride and groom.
No, it's not very much that I would like to say. The most important thing I would like to say is thank you very much. And congratulations with this national agenda on composites. Many people have been working on this in the months that lay behind of us, and I think it's a great success that we have this now here. It's an example of the collaboration that we have within the Netherlands. You have seen the illustrations and lots of talk about that already. It's an example of entrepreneurship in the Netherlands, and it's an example of the ambition that we have and that the composite sector has in achieving all these challenges, in coming up with new innovations, in collaborating together to come up with answers to the challenges that we face. Now, as we have discussed already here, the sector can give an important impulse to growth and sustainability in our future economy and future society, and this agenda may contribute to that. Now, there were certain phrases that I was not allowed to use, so let's say that the Netherlands is very large in the composite industry, in the composite sector, in its innovations, but we cannot do this alone. No country can do all these developments, make all these innovations, make all these contributions to societal challenges on its own, so we need each other within the Netherlands and with other countries. So this agenda is also an invitation to other companies from wherever in the world to join and to contribute to the developments and innovation programs that we have and for the further development of the composite sector. And we see here on the JEC 2019 how the composite sector is developing, how tangible it is, and I hope that if we are 1 year further, we see the further development of that, and that this agenda contributes to that. So congratulations, and I think the next step is now to read it all. I can recommend everybody to read it, and to contribute to making it happen. So thank you very much.
Right, it's very official, and we are that little bit closer. But for now, thank you, gentlemen, for coming up. Do we have photographs to be done? I was told there might be photographs to be done. Right, good. A very, very important final bit of news. But last thing, let's just thank everyone again. And let me tell you that in 15 minutes' time, there will be a networking cocktail in the Holland Pavilion, which is straight out of the Agora stage. If you can see the color orange, you'll be able to find it. It's just there. Join everyone there. Bring your thirst. Bring your questions. For now, let me thank you very much for your attention and wish you the best for the rest of the conference.
Mooi. Ja, heel goed.